Hello and good afternoon and welcome to our annual department town hall. I'm Laura Albert. I'm the department chair of Industrial and Systems Engineering, and I'm going to kick things off today. And just so you know, we are recording and we'll share the recording afterwards. So if you have friends who are missing today's town hall, they'll be able to see it later. I'm going to kind of go through a few updates on across campus, starting with university updates, then college updates, and then department updates. We'll also get to hear from one of our new graduates, Dr. Valerie O'Day, who just defended her dissertation. She'll spend about 10 minutes talking about her research. And at the end, I will tell alumni how they can get involved and stay connected to the department. All right, so we'll start with what's new on campus. This past year, the University of Wisconsin celebrated its 175th anniversary. It was actually a year-long celebration with a number of events. What really excited me was that our total enrollment hit 50,000 for the first time. So demand for a UW degree remains higher than ever. We also awarded 8,586 degrees this past May. And commencement is always one of my favorite times of year, and it was extra special this year because so many of our graduates were graduating from high school in 2020 and didn't have a graduation. So our commencement was actually very well attended, and there's a lot of energy there, even more so than normal. The University of Wisconsin, in addition to being a world-class university, is also a great place to work. It's considered one of America's best large employers, and we've been moving up that list. And finally, we continue to excel in research. One thing that really makes Wisconsin special is the level of research excellence across the university. Nationally, we're ranked 8th in research expenditures, with research expenditures that top $1.5 billion per year. And we've always are very high on all the various rankings that come out, the national rankings and international rankings. As a university, we're ranked 35th in the world and 12th among public universities. Moving on to the College of Engineering. The college has seen a lot of growth in our student body as well. This past year, we welcomed 1,200 new undergraduate students, and we're expecting to grow as a college in the coming years. We also welcomed 420 new graduate students in the College of Engineering. So this past May, we had almost 1,100 graduates, 762 with bachelor's degrees, 238 with master's degrees, and 91 PhD students. Our faculty has also grown. Historically, we were about at 200 or just under 200. We're now at 216 total faculty, with 18 new faculty members who joined us this past year, including one in the department who I'll introduce you to later. We have two big announcements in the college. One is that Dean Robertson announced that he is planning to step down as dean and rejoin the faculty in December. So we will have a search for a new dean this fall semester, and we prepare to welcome a new dean as soon as January. Stay tuned for more. The big news is the approval of a new engineering building, and I want to talk to you a little bit about that today. This building is much needed on our campus. It will be an enormous building, so we'll tear down the old CAE building at 1410 Engineering Drive. I know it's had a few different names over the years. And we'll actually move the fountain. So you might want to visit campus and get your last pictures in with the fountain because you're running out of time. And we'll place a new engineering building in that space. We've actually been planning the building for 2 years, even though it was just approved. So I can share some of the plans with you. While they're preliminary, they're pretty fleshed out at this point. We are definitely excited about this new building. So as we've been planning it and preparing for its approval, I can say that we've gotten everything we wanted and even more. So I want to tell you a little bit about the building. This is a preliminary illustration of what the new building will look like. So this is the view taken from Engineering Drive, kind of by that green space near the football stadium facing northeast. And you can see that's a big building. And the main building, which is in the back, which is a long building that goes along the railroad tracks and bike path on the backside, that is 7 stories tall, so that's above ground, plus the basement floor. And it will be the biggest campus building when it's completed. It's at least it's expected to be, and it will have 400,000 square feet. And this building will house classrooms and labs, teaching labs, research labs, and also industry partnerships. So these are 4 photos. Obviously, the building hasn't been built yet, but these are preliminary interior photos showing what some of the spaces could look like. Again, there are 7 floors. The first 2 floors are going to be entirely student focused with classrooms and lab space for student use. Floor 3 will be a mix of research labs and teaching labs and learning labs, as well as some classrooms. Floors 4 through 6 will be devoted to research with a lot of space for research labs, especially wet labs. So we are not able to make enough room in our existing buildings for wet labs. So this is really much needed for our continued growth and research excellence. And the top floor will be dedicated to industry partnerships, which will be new space for us on campus, and we're excited about that. All right, moving on to department news. So this is a picture of all of our faculty and instructional staff on campus, and I'm going to tell you a little bit more about some of the latest and greatest on our campus and in the department. So that picture on the last slide was incomplete because we will be welcoming 2 new faculty members this fall. Dr. Andy Lee, who joins us from Arizona State University, has expertise in manufacturing and industrial AI. And Dr. Dan Lee joins us from Clemson University, and she has expertise in manufacturing and cybersecurity and cyber physical systems. And both are already assistant professors and will be joining us. They're experienced, they're great teachers, and they're doing really exciting work. So we are also very excited to welcome them. Our department, in terms of our undergraduate and graduate enrollment and rankings, we currently have 312 students in our undergraduate program. So usually what that means is that students maybe transfer in after their first year, and then we see them their sophomore, juniors, and senior years. Our undergraduate program continues to be top ranked. It's ranked 10th among public universities at present. Our graduate enrollment has grown in recent years, and it's now 159 students, and those students are in research masters, professional masters, and the PhD programs. And we continue to have a top-ranked graduate program. The latest ranking that came out last year, we were ranked in the top 10, so 6th among public universities, and new rankings will come out next week, so those are something to keep an eye on. We're really proud of our students. They're really impressive. We have outstanding students. So you have the numbers here, 471 total students in our program. I want to tell you a little bit more about our students. They're very active in student orgs. So many of them in our student orgs, but then many more are active in College of Engineering, student orgs, and campus orgs. Many participate in our ISyE Connections mentorship program. And in terms of placement after graduation, we continue to have the top ranked department in terms of students who are placed after graduation. Our students are incredibly sought out in industry. We're still getting some of the latest numbers from our graduating class, but already 82.4% have accepted jobs for employment, and 9.9% will be entering graduate school. And typically this goes up to about 97%. And that's what we expect in the next couple months. Scholarships are really important to our students. The cost of college is going up. Differential tuition was raised this past year, and we are very fortunate that we've been able to award $194,000 in scholarships to our students. And this is really needed by our students and often makes the difference to them in terms of completing their degree. So thank you to everyone who's given to student scholarships. We awarded 84 scholarships this past year to 61 students. I want to highlight some more about our students because they really are outstanding. There are a couple of news articles that I was reviewing and preparing for today's town hall. One is an article that summarizes our new data science certificate, which is the Engineering Data Analytics Certificate, which is available to all majors in the College of Engineering. So it helps prepare engineering students for careers in data science. And we have started to offer that certificate this past year, and a number of students have already signed up for it, including industrial engineering students. We've also been making communication a priority in education. We've heard from alumni that our students need to improve their skills with communication to really be competitive and to have the impact that they want to have after graduation. So what we've done is use our existing courses, and especially the project-based courses where communication is a large component. And we've welcomed back to many of our alumni to give feedback to students and to help students build their communication skills. And this has been really impactful for our students and is making a real difference. So thank you to everyone who's come back to give back to the next generation of Badger industrial engineers. And finally, we're always revising and improving our curriculum. One new course is a course on data ethics that is going to be cross-listed with ISyE, so electrical and computer engineering. And they taught it this past year, and this will really help and be an important cornerstone in our data science curriculum for engineering students. We have a very impressive set of faculty and students, and just this past year, they have been recognized with so many awards, and this is a big list of awards. I won't read them all. The font is really tiny. Just know that our students and faculty are doing really great things, and it's great to see them being recognized for their contributions. In terms of research, we continue to be an outstanding department in terms of our research. We're innovative, we're cutting edge, and we're making new discoveries that will make a difference to the future of engineering. Our total research expenditures this past year were 9.7 million, and we're expecting that number to grow based on recent awards to our faculty. And among all departments, we're ranked number 2 in both research dollars per faculty and number 2 in the Scholarly Productivity Index. So we have a very productive faculty, so world-class researchers as well as world-class teachers. I want to highlight some of the news articles that have highlighted some of the research contributions from our faculty this past year. The first is an article summarizing Dr. Han-Tang Quinn's research on zero-gravity 3D printing in outer space. Dr. Gabriel Zayas-Caban has also been studying the effectiveness of drug use treatments in prison. So this fuses data analytics and causal inference in a complex system. And we have a number of faculty studying human-centered AI as well as cobots, so human and robot systems that have shed light into how to center humans in systems that have AI in them in the future. An important announcement as well is that I've decided to step down as department chair after my 3-year term and return to the faculty. I really look forward to returning and to doing research and making more time for teaching, both of which I've desperately missed. It's been an honor to serve as department chair these past 3 years, and I'm proud of some of my achievements. Soon I'll introduce you to our next chair, Dr. Xiu Zhou, who's been a faculty member of this department for more than 20 years. First, I just want to summarize some of the department achievements in the past 3 years. In terms of academic achievements, there have been a lot of them. As I mentioned earlier, we're one of the top-ranked programs, both graduate and undergraduate, and we continue to be one of the most respected departments in the country. We're also been working on continuous improvement of our degree programs. We introduced an undergraduate data analytics certificate this past year. We also introduced an undergraduate research program in the department to prepare students interested in research or doing a PhD someday. We've increased enrollment in our master's program. It went from 38 to 98, and this is to help meet the demand in industry. And we've made a number of improvements to our program. We've started an annual professional development for teaching in the department, and our department underwent its internal reviews for our graduate programs, and we've made improvements to our PhD and master's programs as a result of that. Currently, we're renovating our manufacturing lab for teaching so we can prepare students for careers in advanced manufacturing. We've introduced many new courses, and we've also introduced the Inclusion, Diversity, Equity, and Access Distinguished Speaker Series. Over the past few years, our faculty have introduced several new courses. Most of these are at the graduate level or would be undergraduate senior electives. And I won't read the entire list here. There are a lot of really interesting courses that have spanned human factors, operations research, AI, and manufacturing, as well as healthcare. So it's exciting to see us and our faculty have so much energy to keep our curriculum fresh and forward-looking. Alumni engagement has been one of my favorite parts of being department chair. I really have enjoyed getting to know so many of our alumni, and it's been so touching that so many want to help the department and help those next generations of Badger ISyEs and give back in some way. That means so much, and it makes a huge difference. In these past 3 years, we've had several major gifts. We've expanded the department scholarships to really start to meet the demand that's really out there, and there's still more demand for scholarships and more student need. And these scholarships have involved department scholarships as well as STAR scholarships, which is at the college level. And just if I could put a quick plug in, is that there is a match at the college level for STAR scholarships. And that match exists for the rest of this year. So if you're interested, you can follow up with us later. We created a department LinkedIn page, and we'll have a link to that LinkedIn page at the end of this presentation. I've enjoyed Day of the Badger engagement with alumni, many visits face-to-face and over Zoom with alumni. And we've started a number of annual and one-time events, including today's town hall. We have an annual bracketology webinar, annual department golf outing. There'll be a College of Engineering ice cream social in August. And we've had other events such as one-time events like the Milwaukee Tool event, a UW Now panel. And we've also started welcoming our alumni back to campus. So if you're interested, this is another way to give back. We have a Welcome Back Badger series where alumni come and talk to undergraduates about their career journeys. Students love it. And as I mentioned earlier, we have alumni come back to help students with their communication skills in project teams. One thing that I'm most proud of is recruiting new faculty. And I've been able to welcome 6 faculty members to the department in the past 3 years, including the 2 that will be joining us in the fall. And we've really have an outstanding faculty, and our newest additions to the department are really already well recognized, even though most of them are early in their careers. I've listed just the very top awards here under their names, and these are major national awards. And you can see that even some of our youngest faculty members already have major awards, which is a testament to the great recruiting that we've done. So I'm excited because the future is really bright at UW-Madison and ISyE. You'll get to hear more about these faculty in the next few years if you follow our news and read the newsletters we send out. So in addition to these faculty that have joined the department, we've celebrated 5 faculty promotions, including 2 that were promoted to associate professor with tenure, pending the rubber stamp from final approval from the Board of Regents, and 3 were promoted to full professor. We've also appointed 4 individuals as instructional staff and hired 6 staff members. In terms of major recognition in the past 3 years, we've had a lot of major recognition. Again, these are really the top awards that have been awarded to our faculty, our students, and sometimes our former students. And I won't read this entire list, But just know that the future is really bright in the department, and we're expecting to continue to see our faculty and students recognized for their great work. And finally, I'm happy to say that when I step down as chair, the department will be in a good place. We approved a strategic plan 3 years ago, and we've made a lot of progress on that strategic plan. The department is healthy financially, and 3 years ago, coming out of COVID, there were some questions about that. But we've been able to increase revenue from educational programs, increase our research expenditures, and increase, giving and philanthropy. It's also been nice to have so much alumni engagement with our industrial board and the numerous engagements with alumni. And as a department, we try to function well and efficiently, and we've updated a number of our programs and policies. We've even sunset 2 policies that were no longer relevant and started an AI task force to prepare our curriculum and our curricular offerings for the future. And finally, one thing that I really enjoy is increased engagement with students. We've had a lot more social events the past few years, including picnics, game nights, coffee and donut events at department socials. So there's a lot of coffee and sugar, but we're all buzzing with excitement at various times throughout the year. And it's been so nice to get to know the students. So again, it was an honor to serve as department chair. And at this point, I'm delighted to introduce you to our next chair, who I'll give a few moments to speak to introduce himself, Dr. Shiyu Zhou. Shiyu.
Yeah, thank you, Laura. Good afternoon, everyone. First, I will introduce myself a little bit. So I'm Shiyu Zhou, and I got a PhD from University of Michigan in 2000, and I joined our IE department in 2002. I have been working in our department for more than 22 years. I really enjoyed our environment and the support provided from our department. So my teaching and research mainly focus on manufacturing. So I teach a facility planning course, computer integrated manufacturing course. My research focus on data science and AI-based methods for manufacturing process control, particularly quality control and reliability engineering. So I'm mainly active in professional societies, include the Society of Manufacturing Engineers, this American Society of Mechanical Engineers, and the Industry Institute and the System Engineers. So for others, right now I'm married with one daughter. Our daughter is really a troublemaker in our house, but fortunately right now she's at college. So my wife and I just empty nesters, so we really can focus on the thing we would like to do. Besides working, I view myself as a techie. Like I'm really enjoy to learn the new advancement in high-tech industry, different type of technology, advancement in AI, and the different gadgets developed each month or each year. So we're living in a very exciting period of time. So we're in a period of a technological revolution. So it's really exciting. I really enjoyed reading various of tech news. And I'm also enjoy travel and reading. So that's essentially is about myself. Next page. Yeah, Laura did an excellent job and left a big shoe for me to fill. So essentially, I will continue Laura's efforts. I will focus on department resources and my energy on increasing support for our undergraduate students. We want to provide our undergraduate student an excellent experience at UW-Madison. The experience not only include the learning experience, but the general living experience. So we will create different events and the community building efforts to let our undergraduate students enjoy their time at UW-Madison. I also create a task force on undergraduate enrollment. We want to teach the incoming students how great IE is and attract them go into IE field. So I believe it's a disservice of us if we don't tell the incoming student about IE discipline. I truly believe IE discipline is a very versatile and a very impactful profession to be in. And I also want to increase the support for our graduate students. I will identify ways to enhance the competitiveness of our graduate student recruiting and continuous improve the learning experience or living experience of our graduate student, include both master student and PhD student. I will also focus on energy on growing alumni engagement, create more opportunities for alumni to participate in the activities in the department, and also create more opportunities for connecting current students with our alumni. So I'm open to whatever suggestions from alumni, and I'm always available. So if you have any comments or suggestions, just shoot me an email. Okay.
Yep. Thank you, Shiyu. As you can see, the department's in excellent hands. And at the end of our presentation, we'll have some information on how to connect. Next, I want to introduce you to Dr. Valerie O'Day, who just defended her dissertation, and she's going to talk to you a little bit about her important research on learning service systems.
Thank you so much for that introduction. I think this is the first time that someone has called me doctor officially. So thank you, and thank you for all the updates. Today I'm gonna be sharing a little bit with you guys about my research at UW-Madison, advised by Dr. Gabriel Sayas-Caban, titled Learning Service Systems. Next slide, please. So to give you a little background, the motivation for this particular work comes from UW Health. They developed risk prediction models specifically targeting older adult patients who might be at high risk of falling. The input is electronic healthcare records, and the output is the risk score of a fall. And so they have embedded these risk prediction models into their clinical dashboards. And so now whenever a patient arrives to the emergency department, they check in, and automatically this triggers the electronic healthcare records software, and this automatically calculates a risk for this patient in terms of falling. And there are two possibilities: either the risk is low and nothing happens, or the risk is high and the system flags these patients, and physicians can see this flag and intervene on these flagged patients by, for example, referring them to a falls prevention clinic. And so from the system's perspective, what's really going on is that as more patients come into the system, and thereby as more data is being collected by the system, the goal really is to be able to learn from the past in order to improve the system in the future. And this is known in literature as a learning health system. And so to this end, we might want to recalibrate the risk prediction model as more data becomes available in order to make it more accurate, or we might want to even revise the risk prediction model. We might also want to update the risk threshold for assigning an intervention, or we might want to update the referral process itself. Next slide, please. So the goal of this work was to develop a causal inference methodology to understand the impact of these learning health systems or learning systems on patient outcomes. So we're really not focused on the predictions of the risk prediction model, but the consequences on intervening on patients based on these risk prediction models within learning health systems. And so why is this important? This is important because even though there are methodologies such as the regression discontinuity design that are adequate for these scenarios and that are able to handle observational data, they are currently not equipped to handle learning. And this is because learning violates a core causal inference assumption, which is that each patient cannot interfere with each other. However, by the very nature of a learning health systems, prior patients will definitely impact subsequent patients in the future. Next slide, please. So very briefly, here are some of the problem details. This is a directed acyclic graph for a very simplified scenario of only 3 patients in the system. And if we focus our attention on the first patient, we can see that their patient characteristics X determine their risk scores. And depending on that risk score, we have a treatment assignment. And so without loss of generality, even though this risk cutoff could be varying from patient to patient, we're going to assume that the risk cutoff is 0 for all of the patients. And so if the risk score of the patient exceeds the cutoff, then they would get assigned to an intervention. And based on that intervention assignment and on patient characteristics, we get an observed outcome. What's interesting here is that we can see that potentially the patient characteristics, the treatment assignment, and the outcome could potentially impact what happens to the risk prediction models of subsequent patients. Next slide, please. So we want to be able to characterize that interference present in our particular application. And to do this, we move into the potential outcomes world. And this is all represented here in this single world intervention graph, where basically we want to understand how changes in one variable affect others. And so through this swig and through some mathematical proofs, we were able to arrive to the conclusion that the patient characteristics are IID because they are not affected in any way by the treatment assignment. Potential outcomes are also IID because they are only affected by the current patient's treatment assignment. However, the risk, the treatment, and the outcomes are not IID because they are affected by previous patients' treatment assignments. Next slide, please. So now that we were able to characterize this interference, we're able to define a local average treatment effect of interest that is very similar to the one in the regression discontinuity design, which is shown here. The main distinction is that the R's are now not IID, and consequently we have a local average treatment effect that is specific to each person. Next slide, please. And so in order to identify this local average treatment effect, can you click again, please? Sorry. Thank you. We were able to rewrite that local average treatment effect only in terms of observed variables as seen here. Next slide, please. Thank you. And the idea here is that we leverage on our precise understanding of the mapping of the risk scores in order to redefine the notion of local randomization in terms of the model inputs, which are used in the calculation of the risk score. So the idea is that with that W that I introduced in that equation, we are selecting only a subset of patients where if we slightly alter their patient characteristics by a small amount, and that still leads them to having a risk score close to the cutoff, which is 0, then we can treat them as if they were randomly assigned to treatment. Next slide, please. And so here I present the estimation strategy, which builds upon that identification strategy, where the idea is that we are going to use the data collected up until patient I, and we're going to assume that that patient I is the current patient in the system who has the current risk prediction model, because as I mentioned, that risk prediction model could be potentially changing from patient to patient. And so we are going to use that current risk prediction model in system to retroactively estimate what would have happened to prior patients if they were subject to the risk prediction model of the current patient in system. And we also recalculate what would have happened in terms of the intervention assignment. And then what we do is we select a subset of patients where if we slightly alter the patient's inputs by a small amount R, and we're able to make them switch their original intervention assignment, then we assume that those patients are exchangeable or as if randomly assigned to treatment. And then we use those selected patients and we regress their observed outcome until their observed characteristics, observed treatment assignments, and their retroactive risk score. Next slide, please. And so kind of to test this strategy, We did several simulations using publicly available data, and the simulation involved applying a diabetes risk prediction model to non-diabetes patients, basically obtaining that risk score, simulating an intervention, and looking at the outcome of whether or not the patient had diabetes. And we wanted to simulate several scenarios where updating could be taking place. And so we have sort of like a baseline scenario where no updates are being done to the risk prediction model from patient to patient. We also evaluated some recalibration scenarios where we recalibrate the slope and the intercept of the risk prediction model as more patients come into the system. We also had a simulation where we completely revised the risk prediction model as more patients came into the system. And we also evaluated alternative outcomes, for example, the change in weight of a patient. And then we have shrinkage factors to control the extent until which we are recalibrating. Next slide, please. Thank you. And then for all of these scenarios, the cutoff, the risk threshold was varying from patient to patient with the objective of reaching a target treatment proportion of 0.5. We evaluated 3 different patient systems. So patient 1,500, patient 2,500, and 3,500, and then 3 different bandwidth sizes. Next slide, please. Very quickly, here I present some of the results of this study. Here I present the local average treatment effect that we estimated. I forgot to mention in the previous slide that we simulated some treatment effects that we wanted to be able to identify through this methodology, or to estimate through this methodology. And so here I have the 5 main scenarios in the columns, and in the rows, the current patient and system, and the 3 different bandwidth sizes are the different colors. And so for the first 4 simulations, the true local average treatment effect that we simulated was 0.2, where we can see that in general, the simulations were able to capture that across 2,000 repetitions. I'm sorry. And then in the last simulation, the true treatment effect was -5, which also we were able to see that the simulations were able to capture that. We can see that as the current patient system increases, and as we increase that bandwidth size, that bias and that variance decreases. And we can also see that the revision scenario was the lowest performing, possibly due to the overfit in the simulations. Next slide, please. Again, thank you. Very quickly, this is just to highlight that the coverage across the simulations was high, close to 95% for all of the simulations, with the exception of the revision model. And then finally, I just want to mention that even though we're comparing between these updating strategies, by no means we're trying to advocate for a particular updating strategy to be used in practice, rather to showcase that the methodology is able to capture that local average treatment effect across different updating strategies. Next slide, please. And so to conclude, we were able to introduce a quasi-experimental design specifically for these learning systems or learning health system scenarios. We were able to do it while considering the patient-to-patient interference, achieving low bias, variance, mean square error, and high coverage. And we were able to prove that the performance was robust across bandwidth sizes and sample sizes. Thank you.
Thank you, Dr. O'Day, for that great summary of your research.
Thank you.
Before I wrap things up, I want to highlight our alumni engagement. We have an industrial advisory board in the department. It happens to be populated with all alumni at the moment, and a special thanks to Ed Naraki for serving as the chair of the board. And we have more openings that occur on a regular basis. So please stay involved with us if you're interested in serving on the board. It involves 2 in-person meetings per year and some engagement throughout the year. Every year we honor up to 2 of our alumni. And this past year we honored Maria Palma with the Early Career Award and Lei with the Distinguished Achievement Award. And we celebrated their achievements at the Engineers Day in November of last year. And there are many ways to stay connected and get involved. And I can emphatically state that we do better with your involvement. And we can reach even greater heights when you stay involved and give back. And thanks to so many who already do that. The QR code here is the best way to visit our alumni page. It has some forms there, as well as some links to staying connected with us on social media. We are on the social media listed on this site, and it would be great to see you there. You can also connect with me personally on these various social media sites. And finally, I've mentioned some of the ways to get involved throughout the talk. Specifically, our ice cream social is August 15th from 5 to 7 p.m. It should be held in the terrace. So if you can make it, watch your email for an invitation, but you can already put that in your calendar. We'll also have the all-college homecoming tailgate party on October 26th when the football team plays Penn State. And throughout the year, you can contact us to be part of our Welcome Back Badger speaker series, which occurs during the spring semester every year. And you can also fill out our alumni engagement form, which we'll have a link to on the alumni page, and you can let us know how you want to be involved. And of course, reach out to us, Tom Van Wy or Jane Feller, if you want to reach out to somebody and have some questions about getting involved. It was a pleasure to talk with you today. Thank you for those of you who sent questions ahead of time. I tried to answer some of them in the talk, and there's a couple I want to answer right now, and then we can answer more questions that you may have. You can add those to the chat, is probably the best way to ask a question. Starting with some of the questions ahead of time, the first question is how the new building will benefit the industrial engineering department. And it will benefit us both directly and indirectly. So about half of the space in the new building will be educational space, and we'll be able to use those classrooms and labs. And there will also be some mixed use spaces that we'll be able to use for events. So we'll definitely get a lot of direct benefit from the new building. In terms of indirect benefits, this is where we benefit a lot, and the building will benefit all the departments, even the ones who maybe won't move directly into the building. So I don't think we'll have many staff or faculty move into the building or have their labs there, because it's really prioritized for a wet lab space, and we don't have that many faculty that need that type of space. But when other faculty are moved into that new building, that gives our faculty in our department really good quality space throughout the rest of the campus. And so it is going to be a rising tide that helps all departments. There are a few questions about the curriculum, specifically AI, human factors, and business transformation. So yeah, we're continually adapting our curriculum to be forward-looking and valuable to students and to really prepare students for careers in the 21st century. In terms of human factors, it's a very popular part of our degree program. It's one of our pillars of our department. We even have a master's in human factors and healthcare systems engineering, because that specific specialty is very popular with students and sought out in industry. And some of our human factors faculty these days are more analytics and AI focused, and we're absolute leaders in that in the world in terms of like human-centered AI and human factors. So that's definitely pretty exciting. And more broadly, we have a lot to offer with AI. So the new courses I listed, many of those have to do with AI, and we have an AI task force that's going to help advise the department on important initiatives in the curriculum in the coming years. In terms of business transformation, this is covered in our existing project-based courses, as well as engineering economy. And there's a couple of certificates that our students can obtain and that are very popular that prepare them for business transformation. So our students really have a lot of opportunity in that space. We received a question about the CHIPS Act and semiconductor research and degree programs. And I will say that the College of Engineering is pursuing a lot of funding for semiconductors. There's a major research effort going on across the college. And we are also participating in that effort in semiconductor research. So our existing faculty are taking part in that. And one of our new faculty members joining us in the fall has expertise and experience in the semiconductor industry. So that'll be a huge value add for the department. We're not specifically offering degrees in semiconductors yet, but it is, infiltrating our curriculum in important ways. And we're starting to really train students to be able to do research and to work in the semiconductor sector. And there's going to be a lot of movement in that space in the coming years. So stay tuned. There were questions about study abroad and scholarships for students. I will say that many of our students study abroad and graduate in 4 years. And it's nice that our students have so many wonderful opportunities available to them. In terms of scholarships, we would welcome more scholarships. I'm very proud of the scholarships that we do give students, but there's still a lot more need out there that we're not meeting. So scholarships remain to be a high priority for the department. And finally, there's a question about how the department is doing. Is it well known? And the great answer there is that our department is very well respected among departments. And you see this reflected in the rankings where we're always near the top and we're in the top 10. And this is mainly a reflection of our reputation to our peers. And we're making all the right moves to continue that in the future by hiring great faculty members, keeping our curriculum current, and doing world-class research. So the future is bright, and I'm really excited about where the department's going and proud to be a member of this department. And I thank my amazing colleagues for being such great colleagues and helping us with this vision. We've all worked on it together. So
Laura,
with that,
did you
I've
see the-
answered some previous questions, and I'm able to take additional questions.
There was a question in the chat. Did you see that?
I haven't. I'm going to
It
look
just
at it
came
now.
in. Okay.
Okay, so the question is, oh, thank you. You're welcome. How has servicing impacted your views on teaching, research, and future research? So I assume by this question, it's service as department chair. And I do a lot of professional service. We all do as faculty because we have to give back to industrial engineering, the discipline, and that keeps industrial engineering healthy. But service has definitely impacted my views in big ways. One thing that I particularly like about service, a couple things. One is that so much of it is in service to my colleagues. I'm not their boss, they're my boss. And the ways that and opportunities I've had as chair to give back and to help elevate others, whether they be staff members, faculty, or students, it's been very fulfilling. And helping others reach greater heights is so important. And that's something that I'm going to continue to make a priority when I'm no longer department chair, because I really do see the value in it more so than ever. Another thing that I really appreciate and that I'll take with me is thinking about the future. So much of my work is planning for the future of this department specifically, but also the future of industrial engineering, thinking about where the field is going, and deeper than that, thinking about where the field needs to go and how can we continue to be leaders in industrial engineering. And that's a lot of fun to do. And I'm not going to stop thinking about the future. And that forward-looking view is going to definitely affect my teaching and outreach and future research. So thank you for that question. Well, I think that's it for our questions right now. So I want to thank you for your attention and for attending today. It was great to see so many familiar faces join us today. I'm always available on social media or over email, a Zoom call, or better yet, in person, face-to-face. So drop me a line. And thanks again, and on Wisconsin.